Thanks, everyone. Yeah, so as Jim said, thank you, Jim. Ross Goodwin, head of engineering, field engineering at Opaque Systems. So my team's responsibility at Opaque is we work with customers and partners, really just around understanding customer needs, requirements, and helping to plan and execute deployments of our technology. So Opaque provides a platform that enables secure data use and collaboration using big data analytics and AI. And it really enables customers to securely collaborate on data with the underlying technical and cryptographic assurances of how that data is used, ensuring you can maintain your data sovereignty over your data during that collaboration. So today, I'm going to share more about the platform that we provide, how it works, and I'm going to give you a product demo of the products with an example use case focused on financial example, specifically about lenders and preventing loan stacking and potential loan fraud. So, kind of starting at the beginning, there's obviously a huge and growing proliferation of data available to organizations driven by big data and storage availability, along with the elasticity provided by cloud. But the problem here is that the granularity of this data means that more and more of this data is sensitive, which is being collected. And it's obviously a growing public concern. It's impacted by regulation and, of course, the threat landscape around data breaches. And organizations struggle to put that data to work, really releasing the value of that data today. And this is where Opaque comes in. So, and this is a problem that's pervasive across many industries. It's not just limited to the more obvious ones like healthcare or finance. It really extends across every facet of the ecosystems that we live in and interact with. And we see real-world problems when we talk to those interested in data clean rooms, really from a range of industries that you can see here, including from logistics to telco to government, finance, healthcare, etc. OK, so what is the problem here that needs to be solved? So firstly, encryption at rest is a solved problem, right? Data can be securely stored and encrypted, and its contents can be protected to a high degree against the risk of data loss if that data falls into the hands of an adversary. Data in transit is also now pervasive. It wasn't always the case. SSL used to be used selectively, but now it's pretty much ubiquitous in its use. It's used typically for most connections that we use today. But all of this doesn't protect your data end to end, because as soon as you try and use this data, processing it, running queries against it, getting value from that data, that's when the data becomes exposed. And the possible threats here include insiders, hosting providers, malicious actors, even privileged malware that can reside, such as in the kernel, rootkits, these type of things. So what Opaque provides here is the capability really to solve that last problem, which is to provide encryption in use, right? And this means that even while data is being protected in memory, it's protected from an adversary, from malware, etc. And this is what we've been talking about today at the conference, using trusted execution environments and secure enclaves. OK, so to give you a taste about the kind of the demo scenario I'm going to show you today, so we're using for this demo a demo case about lending, and specifically we're using the public PPP dataset, and this is a dataset that was released by the US government under the Freedom of Information Act, and this is basically a full record of all the loan data that was provided during the COVID Relief Fund, or the CARE Act. It's about 11.5 million loans. It was facilitated by about 4,000 lenders, but ultimately it was backed by the US government. And as many people are probably aware, right, fraud was a major problem with this facility. Even recently, around 10% of those loans remained unforgiven, e.g., there were questions about their validity, whether they should be backed by the US government. And this totals around $50 billion, so it's a really significant sum. And even the loans that were forgiven, many of those loans are suspicious and likely to be fraudulent, right? And one of the rules of the program here was that when companies applied to the loan facility, they were allowed to make one application for each phase of this, and they were meant to work with the same lender. And one of the reasons it was really to prevent the risk of applicants applying for multiple loans and try to defraud the system. But there was limited success with that, as we'll talk about. So really the scenario we're talking about here is that had these lenders been able to collaborate better, had they been able to share information, then actually there would have been a genuine avenue to mitigate or prevent much of the fraudulent behavior that happened here, right? So what's really needed is a secure, collaborative environment with privacy guarantees over the data that would enable better fraud detection and better risk management during this process. And the reason this is true is that any given single lender really only has access to their own loan book. They can see loans that they've had applications for, loans that they have outstanding, but that's all they see. If a consortium of lenders can work together, then potentially the data set is much bigger, and they're able to see potentially information about loans that have been provided by other lenders, applications made by other lenders. But obviously that data is extremely sensitive, both for regulatory reasons, but also just for commercial reasons as well. So Opaque provides a platform that allows those lenders to collaborate, to pool their data together, to run, whether it be queries or even ML workloads against that data, to try and leverage that data to provide a mutual benefit for all members of the consortium. And in fact, that can be augmented as well by other external data, again securely. For example, it could be blacklisting information, credit agency data, any other external data sources. And again, those data providers can provide that data securely without any other parties in the collaboration seeing the raw source data that's used in that collaboration. Okay, so if we look about how this actually works. So here's an example, kind of a slide, animated slide that kind of shows you how the Opaque platform works here. So across the bottom here, you have the lenders collaborating this. You have external complementary data, which could be provided by a third party, an enabler, multiple third parties. Any number of collaborators can be involved. Each of those parties encrypts their data securely, and they do that in a location where they control. So they have full custody over that data. That data gets uploaded to the cloud, utilizing Opaque's data clean room, and it resides there entirely encrypted and unreadable by all parties in the collaboration. What can then happen is one of the lenders, for example, they can issue a query. They can try to use that data. That use is governed by a data use policy, which requires approval from all members of the consortium. So nobody can use that data or access that data without it being expressly permitted by people working in the consortium. And then once they do that, the results, the processing of the query happens inside a trusted execution environment in an enclave. The data is encrypted in use during this process. None of the parties get to see each other's data. The cloud provider doesn't get to see that data. Opaque Systems doesn't get to see that data. And when that data is processed, the results from the query are also encrypted whilst in the enclave and returned to storage where they can be delivered back to the querying member. And this means that, again, through the entire life cycle, that data remains encrypted and unavailable to anybody. And because you're not handing the data over, you're retaining sovereignty. It also means that the data access policy ensures that your data is only used in the way you expect, and nothing other than that is ever revealed to any third parties. And this is equally true if you're running an ML workload. So it could be an inference where the request, again, is sent from one of the lenders. That inference can be run against a model which is secured in the enclave, and the data, the response from that could be encrypted and returned to the requester to get their answer from that as well. Okay, so what I'm going to do now is I'm going to give you a quick demo of the platform. Give me a second. Okay. Okay, so in this example, we've got two collaborating parties. Like I say, the number of collaborating parties can be any number. So we have Alice here from lender 1, and we have Bob here from lender 2. So what happens here is that each of them can upload their data. Like I say, the data is fully encrypted. It's uploaded to the Opaque data clean room, and no one has access to the data while it's there. In fact, if we have a look at, if we actually have a look at the data while it's in place, so if we actually look at the storage where the data is held, here, we can actually see, let's have a look here. So this is how the data is stored. And again, if you actually look at the data on storage, it's fully encrypted. So all the data at all times during upload, during use, and during storage is encrypted through the whole life cycle. Then what happens here is that the proposer can submit a query request. So here, for example, this is a query that would allow, for example, a question to be asked, like I have an application from a given address. And this is, the platform, by the way, is based on the highly scalable platform. It's based on Apache Spark. But these runs in secure enclaves. You can propose a job, which is primarily going to be delivered in SQL, for example, which queries the combined data, looking to see if a given address has had any previous attempts to apply for other loans. And if we submit that for review, then what happens is other parties then have to approve this prior to. So if we find here, sorry, the resolution's not quite right. So we see here the job is being proposed. The other members of the consortium can choose to accept or reject that request. And then once that's been completed, if we go back to our other window, the job can now be run. So when that job is run, the data, the encrypted data is pulled into the enclave. The query is executed against the data. The results of that query are then re-encrypted and returned to storage in their encrypted form. And then that data, only once that's completed, the requesting party can see the results of that data. And what this means is the query itself can be as specific as necessary for the use case. So you can ensure that even though the raw data is being queried, none of the explicit details, the row-level data, is ever exposed to any other parties in the collaboration. And then the job is just finishing. And what we see here is the query results in this case actually only return aggregated data. They don't reveal any of the source of the information that was used in the query. And then we can see, what we'll see here is that the applicant has existing loans with other lenders. It doesn't reveal the information about the specifics about the loan applications, who the loan applications are with. It doesn't expose information about the size of loan applications, the dates, or anything like this, but it does reveal information to tell you that this loan probably requires further scrutiny. As you can see here, that this address has made 8 applications. It's made applications to 6 different lenders. So it's got 8 unique applicants have applied from this address for a total of 10 loans. And this is enough not to reveal anything confidential from the data set, but it does allow this lender to take a deeper look at that loan to see if there's anything suspicious that needs further information. And by extension, you can run any queries that you need to, as long as you have the approval of members of the consortium. For example, if I show you some results from previous queries, this is, if you like, a list of all addresses that have made in excess of 3 loan applicants, in excess of 3 loan applications. And if you approve it, the source data is queryable, but again, this only is going to be accessible if it's been expressly approved by the policy defined by the consortium. And in addition to this as well, you can, sorry, excuse me. So in addition to this, you can also, for example, you can really articulate anything you can articulate with a SQL query. So anything you want to query, you can potentially do. Again, it just depends on getting the full approval of members of the consortium before that happens. Okay, so that's the demo. Any questions about this?
Without actually getting the information. So you say, oh, I want, if you don't know the loan amount, you can say, oh, I want to count the number of loan amount that are below this value and above that value, and then zero in.
Okay, so yeah, so I think I can summarize the question. The question is, can you continue to ask multiple questions on each iteration, learn more about the data set, etc.? So this would be true, but bear in mind that the questions you ask are, again, have to be expressly approved by the consortium members. So there's a facility there to obviously prevent that if that's, and similarly, you can ensure, for example, in the queries that, for example, only return the results if there are more than X number of rows. Like, so if you try and craft a very explicit query that would return specific information about an individual, then you can craft the query in such a way and make sure that's approved in such a way that the query can only execute if it provides adequate privacy not to reveal individual row level data. So really the answer about that is anything that's approved by the consortium can be approved. The product also actually provides data access policies around the data you upload as well. So column-based policies, you can provide policies to say that certain columns cannot be used. You can provide row-level policies to say data matching or not matching certain criteria cannot be used by the consortium. So there's a number of policy features that allow you to be very selective about how the data is used by members. Okay, let me just carry on here. And I've got kind of an animated slide here also to kind of show you how this works under the covers in practice. So, this one. Okay, so kind of an overview of how this works under the covers. So Opaque provides, as I say, it's a multi-party collaborative platform. So how this works with, and it is based on Intel SGX and say running Spark inside. So what happens is a member of the consortium facilitates the creation of the consortium and creation of the compute environment that this is going to execute in. That instantiates the enclaves along with the SQL processes. And being that it's based on Spark SQL, it's highly scalable. You can construct clusters of devices to deliver queries quickly and at high scale. Once that's done, we follow the attestation process you've heard about today. And this really ensures the integrity of the environment. It ensures that the code is running the code you expect. It's running on assured hardware that reaches expected levels around patch and security levels. Once the attestation process has completed, it's only at that point that key exchange can occur. And at this time, the consortium member shares their key, which is only stored in the T, in the trust execution environment, which allows that key to be used to decrypt data. Once that's done, data can be encrypted using the key and placed on storage, which is what I showed you in the example from the Azure storage. And then similarly, once other members join the consortium, they follow the same process, right? So they perform their attestation step to ensure that the integrity of the environment is as they expect. They do the same thing. They can share their keys to the environment. The keys are stored in the enclave, so they're encrypted, entrusted in protected memory at all times, so inaccessible to anybody. And again, other members of the consortium can upload their data. And then once this is done, this is where queries can be constructed. And again, those queries are checked against a policy to ensure they're compliant with the consortium requirements around data use. And only at that time, data is pulled into the trust execution environment, the query is run, and the results are produced. And then once that happens, the results themselves are also encrypted and returned to storage, where they can be returned to the requester so they can see the data. And this is all I have for today. If there's any other questions, feel free. Or I'll be available if you want to ask questions directly afterwards if you're not comfortable with speaking out in the room.
So I was just wondering about the scale of this platform with large amounts of data coming in, because first you have to decrypt it, then you have to operate on it, then you have to re-encrypt the results, then you have to stream them back.
Yes. Okay, so I think the question is just about general scalability of the platform because of the potential size of data sets, the requirement to not only decrypt the data, process the data, return the results, etc. So I think one of the benefits we've seen from using secure enclaves as opposed to some other technology like homomorphic encryption or MPC is the fact that the overhead is actually not particularly high. The data is decrypted in hardware on the CPU die using, it uses industry-grade AES standard encryption, so that is encrypted in hardware on the die, which is very efficient. Once it's decrypted, the data can be processed in effectively in clear text inside the CPU. So in terms of scalability of the underlying technology, it's very performant. In terms of scale, because we use Apache Spark, which is a well-proven platform which is used by products like Databricks, for example, it's possible to process very large data sets. Again, Opaque SQL is designed in a similar way as Spark, so you can distribute the query across clusters, large clusters of devices. The data is basically chunked and separated, sent to different parts. There's a query planning facility which allows that query to be distributed amongst those members. So each member of the cluster performs some of the work. The data is then combined and returned to storage afterwards. So much like Spark, the capabilities scale to tens or hundreds of machines or larger, and it means you can deal with data sets in terabytes, tens of terabytes, hundreds of terabytes. So, and that is all true of the platform as well. Hopefully that answers the question.
Specifically around movement of data, I mean, if it's large terabytes, my understanding is they have to move the data into the enclave and then everything into this triangle. Are you doing anything to assist with the data movement from wherever the data is located? Because I also hear customers are trying to avoid creating multiple copies. I don't know you can avoid it to solve this problem per se, but
yeah.
do you have any thoughts?
Okay, so I think the question is really just about data movement. So once collaborating parties put their data into the cloud, how that data moves around the cloud, how you prevent duplication of data, those kind of things. So typically, you can deploy this platform in whatever the region is that you want to deploy this in. Typically, the storage, the blob storage, would be deployed in the same region, so it's local to the compute. So once you move the data into the cloud, it's pulled into the enclaves during processing, which should be a local operation within the region. So you don't need to repeatedly upload the data to the cloud, if that makes sense. Okay. So it's a question, what data is returned to the client?
For the attestation process, how the client verify if the system was attested?
Oh, okay. So how does it verify if the return data is authentic? Is that right?
The Opaque was attested.
Attested. Okay.
Yeah.
Yeah. So the client is a component you typically run in a trusted on-premise environment where you have control over the environment, right? The client itself is a software component that performs an attestation of the enclaves. So before any operation, uploading data, executing queries, returning results, attestation is performed to ensure that you are communicating with the enclave. The data is obviously encrypted with the key, and it's passed over a secure channel to prevent any to prevent tampering or any malicious intent with the data. So the client can be sure that the query was run on the enclave, running the software it expects, running on the hardware that it expects, where it expects. And it can be assured that when it gets the data returned, that's where it came from. Hopefully that answers the question.
Kind of a follow-up to that. How does the client know what the expected values are for some of the measurements in the attestation? How do you distribute those?
Yeah, sure. Okay, so I think this is a question about the attestation process and measurement of the enclave. Yeah, so the client has information, first of all, about the measurements it expects from the, and this doesn't go into the full depth of all the internal components, but basically there's components inside the solution that deal with trust and key management. And what it does is it basically understands the measurements of those enclaves that control the keys. It attests those. It validates the measurements it gets during the standard, using the standard attestation process with, with the report and quote signing from the quoting enclave. So it uses the standard implementation for attestation to be assured that it's, it has all the measurement data, and that measurement data is deployed with the software. If that answers the question.
Thank you.
No problem. Okay, and I think we're down to the last minute, so thank you everyone for coming in and seeing my talk. I appreciate it, and have a great day at the conference.